All right, and our other inequality would go the other direction. And that one is less than, or you could think smaller than, fewer. All right, your first one that you're going to glue in is this exterior angle theorem. So find that one that says exterior angle theorem from 4.2. We're going to glue that in. So the one that's a little bit shorter, the one that says exterior angle theorem. So if I might need some, you just walked in. Alright, so our exterior angle theorem from 4.2, if we go all the way back to 4.2, those of you that were with us, we have our triangle angle sum theorem was part of 4.2, but then we had our exterior angle theorem from 4.2, which told us to add the remote interior angles to equal the exterior angle. Add the remote interior angles to equal the exterior angle. Alright, so exterior angle theorem is to add the remote interior angles. So we're going to add the remote interior angles. To equal the exterior angle. Alright, so if I look at this one, which one is my exterior angle in this first triangle? 4, good. So I have angle 4. And what would angle 4 be equal to? What are the remote interior angles to angle 4? Is it 1 and 2, 2 and 3, or 3 and 1? Yeah, remember that word remote? We talked about the word remote. Where do we normally see that word remote? Like a TV remote, right? When you use the TV remote, do you have to be right next to the TV? No, you can be far away from it. So when you see that word remote, or you think of like a remote desert or island, that's further away. So which ones are my remote interior angles? 4 is the exterior. 2 is one of them because it's inside and it's not next to that 4. Remember, remote means further away. So what other angle's inside but further away? 1. So way back in 4.2, what we learned was that if I added the measure of angle 1 plus the measure of angle 2, it was equal to the measure of angle 4. All right, but now today, the new part, that's what we already learned from chapter 4. Those of you that maybe didn't do well last trimester, that's okay. That's what you should have learned in chapter 4. And if not, you learned it today. Yay. What we're learning today is the exterior angle inequality theorem. Now, if I add two numbers and they equal the third number, and we're only talking about positives, those first two numbers have to be smaller than the last number. So somebody give me any addition problem with positive numbers. Doriana, give me one number. Any number. What? 5 plus. Savannah, give me another number. 6. Will my answer be bigger or smaller than 5? Bigger. Will it be bigger or smaller than 6? Bigger. Why is it going to be bigger than both those numbers? Yeah, I'm adding more, and when I add more, it gets bigger. So my 11 has to be bigger. So in this problem here, when I add a number and another number, my answer 4, angle 4, has to be bigger than both 1, and it has to be bigger than 2 because I'm getting bigger. I'm taking angle 1, I'm adding more to it. I'm getting to a bigger number. Okay, so that's our exterior angle inequality theorem. Says that the remote interior angles are less than the exterior angle. Alright, I'm going to use the same colors as I did up top. So I'm going to color my angle 1 in purple. If you want to color code the same colors, you can. We have our remote interior would be 1 and 2. And our exterior would be that angle 4. Alright, so what I know is we know that angle 1, the measure of angle 1, is going to be less than, I'm going to try and make this a bigger less than sign, that way I don't get mixed up with my angles. So that's an interior angle is going to be less than, what's my exterior angle? Angle 4. Okay, and I can say the same thing with the other remote interior angle. What's the other remote interior angle? 2. So the angle 2, no matter what it is, has to be less than angle 4. Because if 2 and 1 added together make 4, that makes 4 bigger. So they have to be smaller than the outside angle, angle 4. Now, what about angle 3? In this picture, what could we maybe assume about angle 3 based on the picture alone? So angle 3 looks smaller or bigger? Smaller. But the only thing we know about these two angles that are across from each other here is that they make what? They make a linear pair, so they make how many degrees? 180. Can two numbers add up to 180 where the inside number is bigger than the outside number? Yeah, this inside number could be 100. The picture could just be really bad. Okay, we don't know that. So the only angles we do know for sure are those remote interior, the ones not touching it. Okay? So we have two examples here, and then we have just one other theorem we're learning today that's pretty quick. It says, name the angles less than the measure of angle 7. Okay, so first thing we want to do is locate where is angle 7. So in this picture, anyone see where angle 7 is? Kind of, yeah, it's at the very bottom there. So we're looking to see, is that an interior or an exterior angle? Good, exterior. It's on the outside of the triangle. So I need to figure out what are the remote interior angles with angle 7. Okay, and as I look at that, what's one of the triangles that it's connected to? It'll be connected to L to what? LKM. We could look at this first triangle here. LKM. And in that triangle, there's two remote interior angles to angle 7. What are the remote interior angles to angle 7 in LMK? 5 and 4. The only one that I cannot say is angle 6. Even though it appears to be smaller than angle 7, we don't know that for a fact. Now, angle L, though, is a part of another bigger triangle. Because how many triangles do you guys actually see here? There's two smaller ones. What about our one bigger one? Yeah, we could say LKJ. We have this bigger one, too. All right, and if I look at the LKJ, now I'm ignoring this line kind of in the middle. What two angles would be my interior angles to angle 7, my remote interior? I'm covering up that middle line on purpose because we're thinking of this as a whole triangle now. So for my inside angles, what are the three inside angles here? Angle 1, angle 6, and 2 and 4 together make this angle. So what are the remote interior angles to 7? Which ones are further away from 7? Angle 2 and 4. We already have 4, so we can list angle 2 now. And what else? Angle 1. All right, last one on this page. It says name the angles greater than measure of angle 3. That was a mistake on my part. We're going to change that to angle 5. I don't know. This one's just not a good one. We're just going to pretend. Angle 5. Let's go with angle 1. Okay, can we change that to angle 1? Angle 1? Are you guys good with that? Sorry. Angle 1. Yeah, I know. 3 didn't work. There wouldn't be any that would work for 3, so then I was like, oh, we'll do angle 5. But we already talked about angle 5, so let's talk about angle 1. I know. I'm sorry. I made a mistake on it the first time when I printed it, and I didn't think about it. All right. Angle 1, angle 1's a remote interior angle. We need to think what angles would be exterior to angle 1. So what I'm going to do is I'm going to follow angle 1 to the outside of the triangle and see if it continues past that outside. If it continues past outside, then we have our exterior angle. So 8 would be out here. So angle 8 is going to be bigger than angle 1 because angle 1 will add up to angle 8. What about if I follow my other side down? Yeah, angle 7 is kind of on this outside part of that triangle. And then there's actually one more. Yeah, angle 5. If I don't look at this, if I only look at that first triangle, what's on the outside of that first triangle? 5. On the Vice computer. Or what are you looking for? Oh, pencil? Here. Sorry. Alright, you're going to go glue in the next one on the next page. Glue in that second one that says angle side relationship theorem. Alright, angle side relationship theorem. So get that one glued in. Alright, here we go. Angle side relationship theorem. This one is like my favorite theorem because it's pretty straightforward. I like it. Just makes things easy. Alright, the biggest side of the triangle, or the longest side of the triangle, the longest side of the triangle is opposite of the biggest angle of the triangle. The shortest side of the triangle is opposite of the smallest angle. So pretty much sides and angles are paired together, but they're paired opposite. That's kind of our big word here, is opposite. So if you want to underline that, circle it, highlight it, that word opposite is really important here. Alright, so we're going to go least to greatest on these ones. That means our smallest to biggest. We have 2 examples that we're going to work our way through. Again, it should be pretty quick. We'll see how it goes. So on these ones, we're going to go least to greatest. So as I look at this one, this first triangle, I have triangle XYZ. What is my least side? What is the smallest side? Good, 11. 11, and then what? 18, and then 19. Somebody have the right idea, though. When we name the sides, we're going to actually name it with our amounts, or the letters. So what is the side with 11? Good, YZ. So YZ is less than. And we're talking about a length. So when we talk about a length, we actually don't put that segment line in there. We are going to use that less than sign. Which side is 18? Good, we could say ZX, or we could say XZ, either one. Which is less than, what's our last side? X what? XY. Alright, so far this has not had anything to do with our theorem. So far all we've done is looked at those numbers and said what's my smallest number to what's my biggest number. 11, 18, 19, and then we just named those sides. How are we feeling? Good? Alright, now we want to name the angles, but we're going to do the angles opposite of those sides. So when I look at YZ, which angle is opposite of YZ? Is it angle Z, angle X, or angle Y? What would be opposite? And another word for opposite would be like across. So across from 11 would be angle what? X. So we know that angle X goes first because that's across from YZ. Then for ZX, I'm looking across from ZX, across from that 18. If I go across from 18, do I end up at Z, X, or Y? And across is, or opposite is like we're going through the triangle. I end up at Y. Good. Which means, what is my biggest angle going to be? Going through 19. Yeah, Z. So when you think opposite, it's like you're going through that triangle, you're going across. So even though I don't know what the measures of these angles are, it doesn't tell me that angle X is 32 degrees and angle Z is 78 degrees. It doesn't tell me anything like that. What I do know, though, is X will be the smallest. And what will be the biggest? Z. Yep. Alright, we're going to do the same thing with the next one. But this next one, what information do we know to start with? Do we know the sides or do we know the angles first? Angles. We're actually missing an angle, though. How am I going to find angle W? Good. Add the other angles and subtract from 180. Good. I'm a big fan of just doing the 180 minus 28 minus 78. If you want to add them and get that answer either way, we get the same answer. I just like this one better because it's easier to do in my calculator. 180 minus 28 minus 78, and we get 74. So I'm going to throw that 74 degrees up in that W corner angle. Alright, so if I go least to greatest with my angles, which one is my smallest angle? What number? 28, and then 74, 78. So in my head, I'm thinking these numbers first. In your practice today, there won't be a spot for you to order the numbers. So you might want to take out a whiteboard or just a scratch paper and order the numbers yourself, smallest to biggest. All right, so which angle is 28? V. And we do that M angle V. Does anyone remember what does that little m stand for? Measure. Good. The measurement of angle V. So that's how many degrees angle V is. And I'm going to put just a little dot there for angle V. Okay, is less than. Good. W would come next. Again, I'm going to just put a little point at that vertex, at W. And what's my biggest angle? U. All right, so now for the sides, to go from least to greatest, I want to go opposite of these angles. So opposite of angle V. One part of being opposite is that it's not connected to the angle. It has to go across. So which side is not connected to angle V? VW, VU, or WU? Good, WU. So I'm going to color code that with that, whatever color you did with that vertex there, with that V, and then this would be our opposite. So WU. So we look opposite, we're looking at the one not connected to it. Next up we had angle W. So angle W is up here, and I'm looking for that location to tell me what's opposite of angle W, because that was our next angle. Is it VW or VU? Good, VU. Remember, for opposite, we want it not connected. We want it to be across. So across from W would be VW. I'm sorry, VU. And then across from angle U, WV or VW, however you look at that. So if you want to kind of color code it that way, that might be helpful for you to see kind of what opposite means. So this purple U is across from the purple side, VW or WV, however you looked at that. Okay, taking time to